So hey everybody, my name is Ash Davis, and I'm here to talk to you about refactoring legacy code with Kotlin. So the fundamental basis for this talk has come from my experience of using Kotlin afresh in a very large Java project, and observing how people then get very excited about wanting to use Kotlin in Java, or with Java, and then in replacement with Java. So without further ado, let's get started with the slides. So this is refactoring legacy code with Kotlin. But what is legacy code? How do we define that? So the definition is denoting or relating to software or hardware that has been superseded, but is difficult to replace because of its wide use. You might have something familiar in your code base if you have been working for it long enough. That legacy code is, it's this bit of a troubled problem that we always have to solve at some point. However, I choose to go with a slightly different definition, and that's the one from the book on working effectively with legacy code from Michael Feathers. Now, in this book, Feathers goes on to sort of describe describe legacy code as being anything that is not tested, which is quite interesting, actually. And furthermore, this is justified by the position that if you don't have any regression tests, if you don't have any unit tests on your code in place, then you don't have that confidence available in your code. You don't have the confidence to be able to make changes or to refactor or to work effectively with legacy code because you can't be sure that your changes are not going to cause a crash or a regression test. So I like to kind of combine these definitions as anything untestable and anything Java. So let's jump back onto Java. So we all know that Android is built upon Java, and we all probably are quite familiar that Java is just quite out of our reach. We don't get to enjoy all the features available in the latest revisions of Java. I think the stable release is what, 12, 13, but we're still getting excited about having Java 8. And this is because, well, the JVM is not the same as the Android runtime. So Google had to optimize the Java runtime to be able to work with low-spec devices, even though devices are getting more powerful these days. But we have different things like different instruction sets and more optimized environment. So it simply shared an API, and it would actually have a different runtime underneath. And it's because of this API that some trigger-happy company likes to sue people. And I draw your attention to this lovely tweet that always makes me smile. You might be able to see who is ranking #1. So what are these features in Java 8 that we kind of quite like to use or we sort of enjoy? So Java 8 was released in 2014, which is already 6 years ago. But we enjoy using Lambda expressions, method references, default interfaces, try with resources, and most importantly, I guess, streams, because streams allow us to then fully adopt functional and reactive programming. So with Kotlin being introduced in 2018 as a first-class citizen for Android development, this meant that this sort of changed everything. Everything changed a little bit for Java and Kotlin. And later as well, when Kotlin was announced as a preferred language in 2019, this then made everyone very, very happy. But why is Kotlin so freaking awesome? Because you have consistently familiar code. It's much, much easier and familiar to read and write. You have idiomatic behavior, which means that code is going to execute idiomatically to the platform and to the language. I'll go into a bit more detail on what idiomatic code means in a minute. The code looks terse and concise. It's much easier to get a larger implementation from much less code. If you are moving from Java to Kotlin, or if you haven't already done this before, you'll know already how much less code you need to write to actually achieve the same effect. And one of the nice things as well is that it's under aggressive development. You'll notice that the JetBrains team are constantly revising and constantly bug fixing and constantly updating these features so that we're having consistent rollout of new and very exciting features, which isn't really happening with Java because we have to wait for the runtime to be updated or for desugaring to be implemented. So What's one of the nicest things about Kotlin? And I jumped the gun with a slide, but one of the nicest things we prefer about Kotlin is its use of nullability. Nullability is often called the billion-dollar mistake. Why is that? And that's because of the author, Sir Tony Yuhua, who believes that the amount of pain and damage that null has caused over the years is probably surmounted to that of billions of dollars. I don't want to argue on that one. So what does a null check look like? It's pretty much like this. You might have seen this quite a lot if you work on any Java projects, or if you've seen any Java projects recently, you'll know that this is a guarded null check. But this also can be considered defensive code. So what is defensive code? Defensive code is code that's going to behave defensively in order to preserve the crash rate, or to prevent the user from experiencing a crash. Now, it doesn't mean that the user is going to get a better experience. It just means that the app is not going to crash. You're still going to have situations where you have buggy code, or unexpected behaviors, or polymorphic behaviors that just isn't what you expected. And the result of this is it's really hard to debug. So when you compare this to what we can call the opposite of defensive code, offensive code, slide failed. If you compare this to offensive code, which has a zero tolerance policy for errors, or low tolerance at least. If you've ever had to find an error in a RX Java stack trace, you'll be familiar with what I'm referring to here, because it's really hard to find out where the error actually happened, where the exception was originally thrown, because it's gone down through some level of chaining and level of abstraction. So it's really hard to find out where it actually occurred. Whereas if you have offensive code that throws at the first point of failure, it's much easier to find and detect these things. And furthermore, I quite enjoy it myself because it lends a sense of urgency to this feature. So if you, for example, have an unexpected state which is causing a crash, then you're going to have to deal with it quickly. Now, under most scenarios, you might think that is a negative thing, but actually, if you are able to react so very quickly and patch these things properly, then you'll actually find that all the hidden bugs that have gone unnoticed for so long a time start kind of getting fixed properly. Not only with the offensive code approach, but if you take testing seriously as well with it, you'll find that you're actually less likely to get regression issues. So back to Kotlin and its idiomacy, or idiomatic features, basically allowing better readability for a less cognitive load. So what does idiomatic mean? It means using, containing, or donating expressions that are natural to a native speaker here. So don't confuse this with native speaking as in Muttersprache or mother tongue. This isn't referring to a language that you and I might speak, English, German, French, whatever. It's referring to Kotlin Java. So it means that you're using expressions, you're using features, you're using language paradigms that are native to Kotlin, and that as such means that when you as a reviewer coming back to it, it's much more familiar, it's much more consistent with the rest of the code. You can check out a documentation on the idiomatic use of language features on the kotlinlang.org website. Really recommend checking out this resource. It's quite long, it's more of a reference document, but it's worth having in your bookmarks. So what might be these idiomatic code features? So we have things, benefits like consistent, being easy to read, less cognitive load. This means it takes less brain power to actually understand what's going on the screen on the things you're reading. Less ambiguity. It's much clearer what's going on. You don't have to make any assumptions or do some further investigations. It's a bit clearer. Function over style. If you've had any bike shedding discussions about whether to have a parentheses here or whether to use explicit type declarations, you'll know how painful and how time-consuming they can be, which is why it's quite refreshing to be able to review function over style, so that you're actually reviewing the behavior of your code rather than, did I forget to indent this line here? There's also a Kotlin style guide here as well, where you can check out the documentation. This is the one from Android, from Google, sorry, on the recommendation on Android. Recommend checking that out as well. Again, like the Kotlin idiomatic references, it's more of a bookmark than a thrilling read, but nonetheless, I recommend you keeping it. You can also use KT-lint, which is a opinionated linter. They call themselves anti-bike shedding linter, but we still have conversations on our side. And you can also use KTFMT, which is a formatting library from Facebook, which will automatically apply your formatting rules. So back to the title of the talk, Refactoring Legacy Code. How can I start converting my Java code to Kotlin if I haven't already, or how can I get to that elusive 100% Kotlin state? Well, obviously the answer is easy, and knowing this, we can all go home. Thank you all. That joke never gets a laugh. But yeah, so we all must probably have used the shortcut at some point in our life. This is the Option, Command, Shift, and K. This is the shortcut in IntelliJ to automatically convert to Kotlin. Now, this on its own can be a useful tool, but I'm actually going to tell you why you probably don't want to use it as the only tool in your toolchain. Because it sort of makes a lot of assumptions about nullability, and that's the problem with automatic conversion, is that not everything can be automatic. It has to make some assumptions about the behavior of code, because if it changes things from being nullable to non-null, or from immutable to being mutable, or even changes the implementation, then you might actually have regression tests introduced by a automatic refactor, which is not cool. So what might that look like? Here's a very popular example from a very well-known dependency injection framework. It's very clear what it's doing, of course, but this is the Java code. So we apply automatic conversion to this, and we get something like this. Now notice that our values are nullable, and they are mutable as well. So this is because Kotlin can't make any change, or the IDE can't make any changes to your code, because if you are setting it null, that is permissible in Java, but we don't know if we're actually doing this in Kotlin. So it can't assert that about the rest of the state of the application. Furthermore, if you continue to use this, then you have to then use a double bang operator to unwrap it, or you need to require not null, or do any, some of these gymnastics to try and make sure that the state is in the correct way. You can also notice here that we're not using internal, and that's because Java doesn't know about internal. How would Java represent this? It can't. So Kotlin sort of requires you to do it. So crafting manually, we can make some changes and make some improvements here. We can make use of internal and latent it. These are idiomatic features in Kotlin, so we can use them safely. But then if we want to then use it, if it's not been injected, or if we have a failure for injection, then it's going to throw an uninitialized property exception. Now, you might be able to change this and go with something else, like throw a double bang, throw a null pointer exception if you're using a double bang operator, or you might want to, act a bit differently. You could use file.is initialized. But it's important to remember that this is, again, defensive code. It's basically the same as a null check. So you're not actually getting the best benefit you can from Kotlin here. So actually, it's probably better to just stick with the original and just go with offensive code, because this is going to throw an exception as soon as this is, as soon as it detects that you can't actually execute this method on this member, because it doesn't exist. But we can do better than this. We can provide more contextual information. So we say require not null heater. This is a function available in Kotlin that checks and asserts the state of the provided value. And then you can also provide a message that will then give the consumer more information about why this was null. And this is really useful because it allows you to obviously provide some contextual information. If you're familiar with the methods being made available on Android X fragment and activity libraries, you'll know that there are now things like require context, require activity, or require view by ID. What happens in these functions is that they check for nullability, and then it throws usually an illegal argument exception, or a legal state exception, sorry, with an explanation saying view is not attached, view is not a child of this parent, or such. This actually gives you some more useful information rather than just a null pointer. So you can actually then go and debug it with a bit more efficacy. You can go one step further and actually use the Elvis operator as well. And then you can actually build your own custom exception, which is really nice actually, because you can then provide it additional data, you can modify the stack trace, you can add reporting data if necessary, and you can really have like a lot of control over what's doing this. And I started using this approach myself in a lot of code, but when I started doing this, it reminded me of a XKCD comic, which I'd like to share with you, and that is that of an unreachable state. So I'll give you a second to read it, but TLDR, never write error messages, tired. Cool. So another idiomatic feature we can make use of in Kotlin applies to beans, and these are Java beans, not coffee beans. So you might be familiar with a basic user class or a basic class with some, like a basic Pojo class. I have getters and setters, implementation for equals and hash code, and some constructors and private values. So we run the automatic conversion over this, and we get something like this. Notice that our values are actually still mutable, and they're still nullable. But what it's not gotten rid of us for us, even though we could actually lean on the compiler here, is that we still have this equals and hash code function. Now the reason for this is because what could be IDE does not know if your implementation of equals or hash code is going to differ from that generated by the compiler. So if you're making use of these in a way that might not be typical, then that actually could introduce some regression issues. So it's not safe for the IDE to actually make that assumption, which is why you're then going to have to go in yourself and then modify these and update it. So first off, let's make it a data class so that we have these implementations generated for us, and let's get rid of immutability. Let's make them values, and let's remove nullability so that we can then use non-null values. There's lots more about data classes that I can get into, but that's more, I guess, basic Kotlin. So, but there's reasons why you have to sort of hand code this rather than relying on this automatic conversion. So further idiomatic features, as you're probably aware of, are extensions. Now, extensions are really fun to use, but I think we're probably already using them quite widespread. There's an example, a really great example in the Android X KTX library or core KTX library for shared preferences. So you might be familiar with this shared preferences mechanism already. So you call edit to retrieve an editor, and you put the appropriate values that you want to set, and then you apply or commit depending on what your requirements are. But the Android X library provides this function. You can see that it's inlined, so this is actually going to get inlined to your call site. So there's very little overhead of actually calling this function. And then in doing so, you can sort of start building this domain language that looks a bit more idiomatic to Kotlin. So you have this Lambda function that actually has your behaviors inside of it. Now, looking at this, it's much clearer in an idiomatic Kotlin fashion than it was looking at this, which is that's more Java style. So moving on. You can catch a full list of the Kotlin idioms at the kotlinlang.org website. I'll go over a few quickly now, but we have things like default values, where you can specify the default value in a overloaded method. So this might, you would achieve this in Java by declaring the method multiple times with different sets of parameters. Here you can actually just use default parameters and collapse it all into a single signature. You have singleton objects. Singleton objects are often sort of an anti-pattern in some ways, but they're often actually quite useful in some other ways. So you can consider them as objects as more consistent with Kotlin style. String interpolation is one of the most favorite features I've heard of from Java developers, and that's been able to kind of interpolate variables and expressions into a string concatenation, which then goes on to use a string builder under the hood, which is really useful, and it's much more easier to read. Destructuring is super useful as well. If you have a class like a pair or a data class where it has sequential components, then you could then sort of explode into individual variables. This exists in many other languages as well. They have scope functions as well. Now, arguably, you could say that scope functions are often misused, or they're abused in some ways, but I think if you use them appropriately, they can be quite powerful and useful to your Kotlin idiom vocabulary. So one of the questions I've actually received a lot as well about Kotlin or refactoring and moving to Kotlin is maintaining the Git history. So if you have a lot of Git history in your repository about how this kind of class came to be or what reasons were given for refactoring, and there's all this rich history that you have with Git that you do not want to lose. So if you then migrate a file or convert a file automatically, you might actually then lose that history because you're rewriting the whole file. Now this is possible to achieve. You could then you could use Git to rename the Java file to a Kotlin file in one commit, obviously commit that, and then do the Kotlin conversion and then commit that. If you're using Git squashing, then remember that the entire pull request will appear as a single commit in your master history. For this to work, you have to have them as separate commits in the master history, not in your PR history. So they have to be separate PRs if you're using Git squashing. But I would actually argue against this. I think this is often a lazy way of converting to Kotlin. And what I would actually much more recommend is refactoring. Losing the title of the talk, refactoring a legacy code through conversion. This has a really beneficial aspect. A really kind of useful side effect as well is that it gives you a much better perception, a much better understanding of the code that you're migrating instead of blindly moving it over to Kotlin. So let's cover quickly what principles you might want to consider when performing abstractions and refactoring. So you may or may not have heard of solid design principles before. For those that have heard of it, it's actually quite a tired talking point, so I'll try and be brief when I'm covering it here. So solid design principles obviously make up 5 different principles. You have single responsibility, open closed, list-call substitution, and interface segregation, and finally dependency inversion. And what we can see from these principles is that whoever named them really wanted to have that acronym. But basically, the only one you really need to be concerned about is single responsibility principle. Make sure your classes are not doing too much. If they have more than one responsibility, think about how you can abstract it and break it up into different classes. And always remember that Uncle Bob is watching you, because you should be practicing these things anyway. So what does this lend us? It gives us a better perspective on the code that we're refactoring. We have to then actually understand what's going on. We see it from a fresh light. This is the same reason that we perform all these kata exercises or these cones or these dojos or whatever you want to call them, all these kind of repetitive coding challenges to kind of hone our skills, because the more you repeat yourself over a single task, the different solutions you're going to find to it, the different ways you're going to find to approach this problem. And then you might actually find that when you're then readdressing this problem or refactoring, that, well, the original solution was maybe inefficient or could be improved. So having a different perspective on your code is actually really, really beneficial. You're gonna have a better understanding of like why this code exists, and this might be due to business concerns, some product owner thought it was useful, or whatever, but you have to actually understand the business value of this code. And in some cases, you can actually remove code, which is even nicer. That if you can just remove Java code without having to write Kotlin code, that's the best case scenario. Another thing I quite like about this is that static isn't so much of a thing in Kotlin. It's less, it's sort of passively discouraged, which is really quite nice, because static is really difficult to test. It's really difficult to substitute any dependencies in a static method or even mock that method. I mean, I know it's possible, but you have to jump through all these hoops to achieve it, and it's just difficult to work with. So if you are kind of passively discouraged from using static, then you're actually passively encouraged into using better paradigms, which are more testable, easy to use, and give you more stability. So asynchronicity, I'm going to go into this in the next slide, but as we probably all are familiar with, code synchronization is hard, or concurrency is hard, sorry. So concurrency. What is concurrency? Concurrency is management of threads and making sure that you have the expected states, and not to be confused with parallelism. Parallelism is where you can have, if I'll get this definition right, parallelism is where you can have tasks that can operate on individual environments. Think of things like CPUs, which have different cores. They have tasks running in parallel, whereas concurrency is tasks that can start at the same time but finish at different times and then overlap sometimes as well if you have the resources. So of course, in this environment, you might end up with race conditions. You might have a shared mutable state. You might have threading issues. You might have blocking issues. You might even end up with a deadlock. So how do we start a single traditional thread in Java? Well, it's actually quite straightforward, but this isn't very efficient. It scales poorly. It's not encapsulated, and there's no cancellation behavior going on. If you're more familiar with the Java world, you might be aware of completable future. Now, this is a nice chaining mechanism that you can then sort of apply asynchronous behavior as a sequential chain of operations. This is good for unidirectional data flow. And in the Android world, our equivalent is RxJava, where we have chained operations. But unfortunately, sometimes that might get a bit out of hand, and you might end up with RxJava observable chains that do a lot of things that you're not quite sure what they are or why they were there in the first place. Here you can see an example of how RxJava 2 got quickly out of hand, mapping to different types. I think this actually only does about 2 operations. It's quite ridiculous. So yeah, this is escalated quickly. Compare this to coroutines. So coroutines, the next big thing, if not already the current big thing. If you're not already using coroutines, what's wrong with you? So what are coroutines? Coroutines are basically cooperative routines for non-preemptive multitasking. They execute sequentially or sort of sequentially with a seemingly imperative syntax. And it looks a lot like code you might be familiar with in a Kotlin-esque world. So given this example, using straightforward global scope, we have a print line printing hello, sleeping for 2 seconds, and then we have the launch, which delays by 1 second and then prints world. So because we're printing hello immediately and we're printing world after 1 second, this then prints hello world after 2 seconds. So cool. I feel like I should talk about stability about coroutines. There are a lot of parts of coroutines which are stable. And there's a lot of annotations that provide you the idea of what's going on. These are things like experimental, obsolete, internal, flow preview. I think there's now one, they've actually renamed now to be opt-in, which means you can actually design your own annotations and design your own API documentation through use of this, which is really great. And I recommend this talk from Yossi Wolf, where he talks about building SDKs using these annotations to your advantage and how you can utilize this to give your API much more meaning. So moving back to refactoring legacy code with Kotlin coroutines. So the nice things here are that we're using a native library. So coroutines isn't like a second-class citizen to Kotlin, like RxJava is to Java or any of the Guava things. Like it's something developed after the fact. Like coroutines is part of the language. Even if you have to you import a library, it's still language supported. It's incredibly efficient. You can spawn thousands and thousands of coroutines and not see much impact to your performance. It's really easy to use, and there's something somewhat gratifying about writing suspend fun all the time. I think it's just a nice thing to do. So let's go back to our example that prints hello world after 2 seconds. Let's say you have some very complex asynchronous behavior where a lot of concurrent operations going on. And you might want to refactor this. So how would you do so? Well, you can actually do so quite easily in coroutines. So you just move it to a new function. This function is now suspended, and it delays and prints world. It has no knowledge about its execution environment. It just prints world. So then you can launch it in a coroutine and execute it. This is really useful if you want to extract things into new classes, new methods, new behaviors, because you're not tied to, excuse me, not tied to any other dependencies. You can just say this method suspends. Now, fun fact, you can actually write suspend fun without using coroutines as well. You just can't consume it. You can also actually specify dispatcher as well. In the example here, I've specified dispatchers.io explicitly, but I recommend not doing this because you won't be able to replace this under test, so you want to be able to inject it. There's a great library from Rick Bussero where he overrides or kind of overloads the Kotlin coroutine context with the dispatchers. Then you can call inline execute with dispatchers.io. And this is even easier to test as well. You can just call run blocking test, and then you just execute your functions as you would normally. It's important to remember as well, though, if you have like a infinite suspended function, like a flow collection that doesn't actually terminate, you will actually block your test as well. So you might want to have multiple executions of run blocking tests or launch async where appropriate. You can find the Kotlin testing library here. I can't remember if we're still on version 1.33, but if not, then I'm sure you'll find the right version. Some further reading for you if you're interested. There's a code labs on migrating from Java to Kotlin, which is super useful. There's the Kotlin coroutines test library on GitHub. All of this is open source. And we have this video that I have embarrassingly forgotten the title to, so my apologies there, but I'm sure it's very cool. And this comparison between RxJava made by some other developer that's totally not me and totally not trying to shamelessly self-plug his own content. So in closing, thank you all for listening. That has been Refactoring Legacy Code with Kotlin.
Thanks so much, Ash. Really appreciate you joining this. You know, one of the downsides of a webinar is that you don't get these audible feedback. So I've prepared the clapping app for you. I'm going to give it a couple taps here. Bravo. So just that's special for you today, just so you can get that audible feedback. So we have a great list of questions lined up for you that have been collecting this time. So I'm going to have Uli share his screen. I'm going to shut off my video, and you should see then at the bottom of your screen all the questions from Slido that have been voted on come up. So we've got about 10 minutes, and I'll spring back in here with video and audio as soon as we're ready to jump to Dimitri on the next talk. So feel free to read the question and jump at it.
All right, cool. Just let me know when I've run out of time. All right, cool. When to use lazy and when to use late init var? It's a good question. So I would also like to throw in the fact that you can also use the non-null delegates as in addition to lazy if you are trying to avoid nullability here. So each of these three options, lazy, late init, and non-null, are quite similar. Well, with the exception of lazy, it's a bit different, but it's really up to you because each one has some pros and each one has some cons, and it really depends on your use case. As long as you understand the benefits of each one. So for example, lazy is actually going to create a delegate property for you to use. So this is actually an object that has to be created. So there's memory consumption there. And also it has an underlying implementation about how to handle thread safety. So by default, if you don't specify a thread safety scheme, it will then use what's called a double lock synchronization, which means it checks for the existence of the variable, then does synchronize block, then checks again. And this kind of operations can be a bit expensive, especially if all you're trying to do is offset the initialization. But the benefit of that is that you get to use a lazy property that is immutable. So compare that to late init. A late init is obviously doesn't require any object instantiation, so you don't require any delegates there, no fancy language features besides late init. But the problem there is that it's mutable. You have to then set it, so then it can be actually changed again. So you won't be able to benefit from immutability there, and it can still be null because if you don't set it, you'll still get an uninitialized property exception. Whereas lazy there's no chance of that happening. Same applies to non-null. Non-null and late init are very similar, except that one uses the delegate and one does not. So I hope that answers your question. Any reason why Coffee Maker was using field injection and inject internal latent instead of inject constructor? Yes, very well noted. This was purely a contrived example. There was no reason at all other than the fact that I wanted to show that if you use injection on, if you use field injection, which we often have to do in Android for activities and fragments, unless you're using the fragment factory or activity factory, we still have to make use of these field injections. This is why late in it, and this is why I wanted to talk about nullability in this aspect. If you are using constructor injection, then good for you. You are a good citizen. Always prefer constructor injection over field injection because then you can actually then rely upon immutability and nullability and null safe values without having to worry about any of the overhead of using non-null or late in it or lazy. Thanks. Any suggestions on a good article to understand the scope idiom? There are a lot of examples out there. Unfortunately, I can't think of one off the top of my head, but what you're probably want to find out is the reasons why to use different ones. So there are four main scoping methods. That is apply, also, run, and let. Now, each of these basically have a different signature that make them better for use in different circumstances. Apply and also will return the object that you call the method on, and let and run will actually return the last expression in your Lambda block. So you can think of let and run more as like a map than having additional features. Also, apply sort of like and do this as well. But the difference in these two in these two is that they have a different signature, where instead of the Lambda property receiving the receiver as a argument, you receive it as a sort of context. I'll try and find a good article that explains this in depth and the pitfalls as well, and I'll try and share it on Twitter if you follow me. Good reason to follow me. Okay, thanks. So next. What are runtime, compile time, performance implications of using Kotlin syntactic sugar if it needs to convert it back to Java-style bytecode? Whew. Good one. So I think it's important to remember that the Kotlin compiler is like hyper optimized. The JetBrains team work extensively on these on the Kotlin compiler, and it's this is probably going to be happening mostly in compiled in build environments. So you're not going to have as much of the issue performance because you've already compiled it and such. There is going to be probably a small impact or overhead in some circumstances, but in most of the time it's going to be negligible or non-existent. So I would probably say the benefit of using some of these kind of idiomatic features outweighs the cost of having any performance impacts, if there are any, that is. Okay, so next question. Did you refactor the legacy code at once or piece by piece? Which approach did you prefer and why? Definitely piece by piece. Don't try and attack everything in one go, because you're going to end up with like a really bug-prone environment. If you try and refactor everything in one go, then you're doing way too much, and you're not going to benefit from being able to understand the requirements, the reasons why this existed in the first place. And it's much better to sort of go with a Boy Scouting approach. Boy Scouting approach is where you, if you're working in that area of the code anyway, then just work in that area and in its surrounding areas and make it a little bit nicer than the way you found it. And then over time, you'll find you have a better understanding of the code, you have a better, cleaner implementation, you have more testing, higher test coverage if you want to use that as a metric, and it'll be much safer way of doing it. It'll take longer, admittedly, but it's much safer. Cool. People try to avoid the double bang or the question mark. Could you mention some cases when these are fine to be used? Yeah, sure. When we started using Kotlin, of course, the double bang operator was seen as abhorrent. It was ugly and horrible and nobody wants to see it in their code. So everyone starts using anything else they can find. So either question mark, or you might have non-null, you might have late in it, you might have these throw exceptions. Personally, that's what I prefer to try and do, is to avoid double bangs by having eager throwing exceptions. It works well for me. But there are situations where something you are categorically sure that this can never be null, but simply it's annotated from Java as being nullable. There's nothing you can do about that, and it's like an impossible exception. I refer back to the slides of the impossible state exception, where you're very sure this is never going to happen, and even then, it can be useful to throw an exception if there's even the slightest remote possibility. But if you are categorically 100% sure that it's not going to be null, feel free to use double bang. I mean, it means that you've thought about the use case and you've considered the language features, because double bang is a Kotlin feature. It's acceptable for use, in my opinion. Just make sure you do so carefully and with consideration, and not just as a fallback.
All right, Ash, we've got time for one more question. Looks like the next two questions were voted on the same number of times, so I'm gonna let you choose which one of those questions you want to answer.
Okay, so they've disappeared. Oh no, they just been voted on. Okay, so Akshay has been voted. No, they're now the same. I'm going to answer them quickly. Statics may be discouraged as they are members of a companion object, but aren't top-level functions, and vars in an object technically static as well. Yes, this is true. This applies also to extension functions, which are technically static functions. But it's important to remember that you consider it how it is perceived in Kotlin. So you might have a top-level function, but then it might end up in a Java class anyway. Now, it might be wrong to say they're discouraged, but like you can actually sort of interpret from the language itself that it's used less, or at least the static keyword was just not included anywhere. And that's because static can mean a lot of things. It can have a lot of results, a lot of side effects. Yes, you're right. But I think we can still take the benefit of these things and still benefit from these. Actually, as well, I think using Mockito with extension functions can actually be successful. But to very quickly answer the second one, because I'm going to do both. Any suggestions on using coroutines when calling Kotlin from Java files? You can't. Sorry.
Well, that was a quick answer on the last one. Anyway, thanks again, Ash, for being here. Really appreciate this session. I know we're looking forward to potentially hearing from you again later in our Jetpack series. I think knowing you for a while, I'm sure you would describe yourself as a lifelong proponent and of fragments, right? A lifetime user, loving it. Never been skeptical about it, right?
Nope, never. Always been a fan.
So yeah, I know we might. Just everyone joining us today, if you come in on one of our future Jetpack series, you might be seeing Ash again talking about his experiences with fragments and navigation library and implementations there. So Ash, thanks again for being with us today. Look forward to hearing from you again. And I'm going to now. Thanks so much.